Hi everyone. So now we want to discuss the R implementation of local regression. So local regression, that we use the LOESS, lowest function. So this stands for local estimated scatter plot smoothing. So LOESS function, and we fit nil on time, and we have to specify the parameter s, the span. So 0.2 means that we use the 20% of observations to fit the each value f hat of x naught. So if just we type this, so this is in the default, the stats library in R. So it outputs several things. So number of observations and the equivalent number of parameters. So in some way, so this is a kind of the degrees of freedom and the residual standard error. So yeah, and if you type, okay, so we name this as, for example, LOE 0.2, then you type fitted of LOE 0.2, you can get 100 observations. So this is fitted value. So you can plot this. So plot of time nil. So this is observation, the scatter plots of original data. Then you can use lines function and time and fitted value. Then maybe color 1. Then you get this fitted curve. So 0.2 is relatively small number. So it's bumpy, the volatile curve. So maybe it overfits the data. If we change this into 0.5, so we define LOE 0.5 as lowest span 0.5, then we overlay this graph. Then red one. Red one is more reasonable, the smoother curve. Maybe black one fits better, but the red one is more natural curve. So as S gets larger, basically this uses 80% of observations. So then we fit this green curve. So it's much the smoother and it looks much simpler curve. So if we use 1, then that becomes just the flat straight line. It's not entirely clear that what weight function R uses. So the R claims that we give the same weight for all observations, but not exactly. For example, the endpoint, how to use the weight. Probably that is a little different from just equal weight of all observations. So, but basically this is the implementation of our local regression. And again, we have to optimize S. If we compare these three lowest, the local regression, and compare residual standard error, residual standard error is the smallest for S is equal to 0.2. So it looks like 0.2 is the best, but this is just a simple fact. So smaller the S is, the fit is better. But this is in sample fit, so it does not necessarily mean this is better. So we have to use some methods such as cross-validation to optimize S, and you have to code it. So LOESS function doesn't automatically optimize S. Okay, so this is our implementation of local regression. Okay, see you then.